Okay, so we're looking at cancelling down fractions here, but it might be called simplifying. What we're aiming to do is get these numbers as small as possible. There's a couple of reasons. One is because we see it easier when the numbers are smaller. And second, well, they ask you in the exam. You want to get it into its lowest form because it's worth a mark. So there's motivation in a couple of ways. 18 over 24, the traditional way would be to look at 18 over 24. If you've got some sense of working with these numbers before, you might know what goes into both. If you're stuck, I can see that both of these are even. If that's the case, then it's most certainly true that 2 will go into both of those numbers. In order to keep things balanced, we have to divide the top and the bottom by the same number. And we've chosen 2 because it's a common factor, common to both. What does it look like if we do that division? 18 divided by 2 is 9, and 24 divided by 2 is 12. Okay, so it's smaller, the numbers are smaller. These are in fact the same fraction. 18 parts out of 24 would look the same proportion as 9 over 12. But it's not in its lowest because I can see that 3 goes into both those numbers. So we're going to do a division by 3. Now this would become 3 over 4. Now 3/4 is the lowest form. One indication is that 3 is a prime number, and primes, they only have certain factors. Okay, so we're not going to be looking for a factor that's in 3 that's also in 4. With it being prime, only 1 and 3 go in, so it's pretty much its lowest form. Okay, now there is another way of looking at this, because the way we did it there, where we're told to look for a common factor, is not really showing the problem clearly. If I show it clearly, and I'll use a different color for this, we have 18 over 24. If we do divide by 2, what we're saying is that there is a factor of 2 in the top and the bottom. What that would look like is this. 2 multiplied by the 9 would give us 18, and 2 multiplied by the 12 would give us the 24. And in essence, these will cancel out the 2's. They will cancel down because 2 divided by 2 is 1, which means that it won't be there. And for illustrative purposes, we'll get rid of it just there, and you'll be left with the 9 over 12. Let's fast forward again here. If we're dividing by 3, we're saying that there's a factor of 3 on the top and the bottom. Visually, that would be a 3 times 3. And on the bottom, there's a factor of 3. That must be multiplied by 4. Again, the 3's will cancel out, and what you're left with is the 3/4, which was our final answer. This can be done in one step using the prime factorisation. So if we take 18, and we remember from another video, or if you don't, you might want to look at prime factorisation. It means finding the factors of a number that are prime numbers. You can split 18 to 2 and 9, 3 and 3. We underline the prime numbers. So a product of prime would be 2 times 3 times 3 for 18. For 24, we've got 2, 12, 3, 4, 2 and 2. And the product of prime here would be 2 times 2 times 2 times 3. If we write the 18 over 24 as the product of primes, we have the 18 on the top, which was 2 times 3 times 3. I'm going to give it a bit of space there. And then we've got the 2 times 2 times 2 times 3 on the bottom. We'll consider now which pairs are going to cancel. So we can see that these will cancel, and these can cancel. And we have none others that cancel. What we're left with, however, is 3 on the top And on the bottom, 2 times 2, which is 4. So there's a couple of ways of doing that. Obviously, this way is probably the fastest way of doing it, but this shows a great understanding of where it all came from with prime numbers. Here's another example just to make that more concrete for you without all of the background in the way. So we have 84 over 126. It's good to see a fraction that's so large because you don't always know straight away what the factors are for both of these. You could do a prime factorization, but a great way to start this is divide by 2. I see they're both even, and so I'm going to start with that. It doesn't matter how many times you have to do this division. If you start easy, you get going, and then the numbers get smaller, and then it gets easier to see. Let's see where we are. 42, if we divide by 2, and 63. It's a little bit easier now. I can see that we've probably got a factor 7 going on. So I could jump straight to that. If you know your times tables very well, that's a good thing because it will save you a bit of time. So we divide the top by 7, we get 6. We divide the bottom by 7, we get 9. Now that feels like, because we did such a big division, it feels like it's the end of it, but you have to be doubly careful, even though these numbers are smaller, to see that in fact there was a bigger factor. We need to go on and divide again for 3. So that would be 2 over 3. That both are prime. We finished. On analysis, at this stage here, we could have seen the bigger factor, although it's very hard because you don't know your 21 times table. But at this stage, if we divide by 21 on the top and the bottom, then we would have gone straight to 2 over 3, as you can see. And what is 21? 21 is the multiplication of the 2 divisions you made to get there. So don't stop dividing until you see prime numbers.